MRI, or magnetic resonance imagery, is a relatively new technique that rests on the electromagnetic properties of atomic nuclei. The patient is placed at the center of a very powerful magnet, which forces the nuclei of hydrogen atoms of his body to align themselves with the magnetic field. A radio wave perpendicular to the principal field is sent in order to excite the hydrogen atoms, which enter a state of resonance. At this stage, the hydrogen nuclei absorb energy. Then the magnetic source is turned off. The hydrogen atoms return to their initial positions, releasing the energy that they had stored in the form of a new radio wave. It is this wave sent back from the matter which is detected and analyzed by a computer, in order that it be transformed into an image. It's true that the energy emitted by a single atom is extremely small, but hydrogen is present in every water molecule, and water makes up around 70% of our body mass. We have here a cumulative effect which explains the exceptional quality of the MRI photographs produced. The patient must first of all remove all metal objects. If his or her body contains a cardiac pacemaker or metallic pins, the examination cannot be carried out. The patient lies down on the examination table and an antenna is placed around the region to be examined. The table is moved completely inside the tunnel. The electromagnets are turned on to generate the powerful magnetic field upon which the radio wave emitted by the antenna will be superimposed. Later, this same antenna is used to capture the signal sent back by the atoms when the radio emission stops. Several sequences are carried out, each lasting 2 to 5 minutes. The patient must remain completely immobile. This examination is completely painless. By carrying out several sequences, almost all of the tissues can be explored, on the condition that they contain water. MRI is thus not used in the examination of bone. In this photograph from a cerebral MRI, the images that have been obtained have excellent resolution for contrasts. It is possible to produce sections in all spatial planes. Computer processing, as with the CT scan, make it possible to reconstruct a three-dimensional image. MRI has led to significant advances in the diagnosis and treatment of neurodegenerative diseases. Lesions in nervous tissue involve an increase in the proportion of water, which is revealed by a hypersignal. In this image of the brain, clearer regions can be noticed which could correspond to plaques of demyelination observed in multiple sclerosis. The precision of the images can be increased by injection of a contrast medium called gadolinium. This other photograph shows regions of degeneration that could be attributed to Alzheimer's disease. But in this case, the MRI serves above all to eliminate the possibility of other pathologies, like, for instance, a tumor. Functional MRI is an application of MRI to the brain. The end result is to be able to follow the activity of a region of the brain using real-time observations of variations in the oxygenation of the blood, more specifically of hemoglobin. Hemoglobin transports and delivers dioxygen to the tissues. When hemoglobin releases dioxygen to the tissues, we say that oxyhemoglobin is transformed into dioxyhemoglobin. Deoxyhemoglobin reacts to the magnetic field and produces a signal that can be seen in the images. Thus, the areas of the brain that are involved in a specific activity can be identified and possible anomalies detected. The electromagnetic radiations used in MRI are painless and do not present any health hazard. On the other hand, certain precautions have to be taken because of the strength of the magnetic field. Thus, no metallic object can be allowed in the examination room, and the patient, like the personnel, must not be wearing rings, necklaces, or even makeup. Because of this, the examination is absolutely contraindicated for patients who have metal prostheses or a cardiac pacemaker. It is a long examination that lasts 15 to 45 minutes. It is noisy and can bother people who are claustrophobic. These drawbacks can be lessened by prescribing earplugs or sedatives.